Hey everyone, it's Justin again. In the last few lessons, you learned how to factor quadratic functions, and you learned how to factor out a GCF. But some quadratics have a GCF, which means you'll have to use both methods on it at the same time. At the end of this lesson, you will be able to factor polynomials with monomial and binomial factors. First, we'll try to factor a polynomial with a leading coefficient. And in the process, we'll see why a different approach is necessary. Then we'll learn that the best way to handle these polynomials is by factoring out a GCF and then the binomials, which we'll practice with some examples. Finally, you'll have a chance to try it yourself. Here we've got a polynomial, a second-degree polynomial, which we would call quadratic. We already learned how to factor quadratic, so let's do it. We need factors of 96, which also add to make 28. So what multiplies to make 96? How about 2 and 48? Except that doesn't add to make 28. It's 4 and 24. They multiply to make 96 and they add to make 28. So the factors are x plus 4 and x plus 24. Red isn't wrong. That leading coefficient. If we redistributed this, it would be 1x squared, not 2x squared. Okay, fine, then we'll just stick a 2 on one of those leading terms and voila, the leading term will come out to 2x squared and, Okay, so now that messed up the middle term. Clearly, this isn't working, so let's rewind. Here we've got a polynomial, a second-degree polynomial, which we would call quadratic. But this isn't like the other quadratics we factored. There's a leading coefficient. That can mess up our calculations. We try to factor using the whole find the right combination method from before. The best thing to do here is pull the leading coefficient off the quadratic, which oftentimes is as easy as factoring out a GCF. So what's the greatest common factor in all of these terms? They're all divisible by 2. After dividing all of the terms by 2, we get x squared plus 14x plus 48. Now that the quadratic function has no leading coefficient, we can factor it using the usual method. Notice how after we pulled out the GCF, it never actually left. It stayed there all the way to the end because the GCF is one of the factors. It's just a monomial instead of a binomial. Let's check our answer just to be sure. We redistribute the two binomials by FOILing, and we get x squared plus 14x plus 48. Like we said before, the two binomials aren't the only factors. The monomial GCF is also a factor. So we redistribute that in as well. And there it is. We're back to where we started, proving that we found the correct factors. Do note that since distribution is just multiplication, we can choose to multiply this in any order. If you feel more comfortable going left to right, you can, and you'll still get the same answer. You could even leave that middle binomial, x plus 6, for last, and it won't make a difference. What matters is that you distribute two of the factors together, then distribute the last factor into that product. So that's the basics. Always try to find a GCF first, especially when there's a leading coefficient. Only after you've done that should you factor the quadratic function into binomials. Sometimes you can't even see that there's a quadratic. In this example, a GCF has made the polynomial a higher degree. Can you identify the GCF? Every term here is divisible by 3. And it has at least 3 x's that can be factored out. So that's part of the GCF as well. If we divide all the terms by 3 and subtract 3 from the exponents because of the quotient rule, we get x squared minus 2x minus 15. Now that is a quadratic function. The combination of 3 and negative 5 multiplies to make negative 15 and adds together to make negative 2. So those are the constants in the binomials. The factors of the original polynomial, 3x to the 5th minus 6x to the 4th minus 45x cubed, are 3x cubed, x plus 3, and x minus 5. Here's one for you to try out. Pause here and see if you can factor this function. First, let's look for a GCF to pull out. The leading coefficient is negative, so we should automatically pull out that negative, which will change the signs of every term. The positive becomes negative, and the negatives become positive. All of the coefficients are even, so we can divide them all by 2. And every term has at least an x, so we can pull that out as well. With the GCF of negative 2x, that leaves x squared minus 9x plus 14. We could factor that using the combination of negative 2 and negative 7, so the factors of 2x cubed plus 18x squared minus 28x are negative 2x, x minus 2, and x minus 7. I'll leave it up to you to check this answer and make sure it's correct. There are a lot of different polynomials, and they all require different methods to factor. As we continue learning new factoring methods, keep in mind that you might need to combine multiple methods in order to factor any polynomial. It can get complicated, but practice makes perfect. See you next time.